talk about a couple of ways you can actually measure this. So this is where you'll also hear the metric called recall. So these metrics, I'll say right now, before I show you the definition, precision and recall and accuracy are the three things you'll hear over and over again. And because they basically they trade off of each other. Essentially is that usually you have good accuracy, but maybe not great precision. And you have to have this balance of saying what's the most important. So going off of precision and recall, note that they're basically inversely related to each other. You tend to not do well with one, like you tend to do good with one, it means the other one didn't do as well. So we'll kind of talk about what this looks like. So this actually, I grabbed this from the curriculum itself. I had another one that was from Wikipedia. If you search Wikipedia precision and recall, you'll see a very similar kind of graphic as this, but I pulled the one from the curriculum since you guys will see this again. So essentially you can think of this graphic here as representing, there's a little bit going on here, but this whole circle is like all of the data, okay? And that these squares right here, these darker squares, are basically representing as things that are, let's say just two classes, 0 and 1. So positive or negative. So 1 being, positive, 0 being negative. So you can think of these guys right here that are dark are actually positive, right? And then the ones that are like hollowed out, those are negatives, so 0, so empty, right? So this is the whole idea. If you imagine took away all this extra color, you just basically would have data that's either positive or negative, right? And then this blue here, and I'm sorry, not this blue, this is confusing me a little bit. Everything on the, I should say everything on the blue side, which is the dark one, is a true positive. I mean, that's actually, 1. And then everything on the right here is actually 0. So that's what this orange is representing. So you can see it also represented with the kind of filled in, okay? So what this guy represents in the square here is basically all the elements that we think are actually true. So imagine this model essentially saying, okay, these elements right here, these are the ones that are actually positive, okay? Now, in reality, you can see that some of them are positive, but maybe our model catches a few not positive ones. So this would be if it's like a false, for example. So these are kind of like all the things that it thinks that are positive. Everything outside of this square, so outside of it, but within the circle still, are essentially, it's the model saying these are negatives. These are not actually positive. But in fact, we can see that there are some positives over here. There are some ones that are negative, which it correctly identifies, but there's some that are definitely, what's it called? That are positive, but we identified as negative. Does that make sense to everyone so far? Hopefully I didn't confuse you guys more verbally saying that out loud. But essentially you can think of that all of these things right here in blue are in fact positive. All of these things in orange are actually negative. But this right here inside this square is what the stuff the model says is actually positive, or you can think of the first group, okay? So if you were just talking about accuracy, which we'll talk about in a second, you would just basically say, all right, how many did it get right in here? It's like, okay, got 1, 2, 3, 4, 5, of this many right out of the total number. But you might say like, we might actually care about what kind of things it gets wrong. So you say like, when it says we get it wrong, did we mostly get true negatives? I'm sorry, false positives, or did we get false negatives more? So you might care about what that looks like. And we talked about false negative and false positive before, is that right? I think you guys recall, okay. Remember, just a false positive, can mean different things. If it's something like a disease, this might matter in the sense of like, what do you care more about? Are you okay with making false positives? Maybe that's perfectly fine, but a false negative is like a really, really bad thing. We need to avoid as false negatives as possible. Accuracy by itself, like we saw true or false on that implementation, isn't going to be enough. So this is where we get into something called precision and recall. So you can already see here, if you're really kind of looking it over, is that precision basically is saying of all the things that we say are true, okay, how many are actually true? So how many of all the things that we say are positive, how many are actually positive? And you can see here, that's what that percentage represents. So if you imagine we have 1, 2, 3, 4, 5 that are actually true, and then 3 more that are false negatives, this would be 5/8, right? So our precision then would be 5/8, or what is that? That is 62%, right? I think that's right, 62.5%. So the whole point is like, okay, our precision would be 0.625, okay? Now, a recall is a little bit different. In this case, we are looking at just the positives, the actual positives. We say, of all the actual positives, how many do we actually label as positive. So we can see here, we got 5 true positives out of 1, 2, 3, 4, 5, 6, 7 out of 12. So we got 5 out of 12 correct, essentially, for this recall. So we'd have 5 over 12, which, quick math, right? That's almost 50%. It's a little bit under 50%. What's that? Like 43-ish percent? That seems wrong. Anyway, moving on. It's under 50%, right? So the whole point is that we have a smaller number. And so this precision and recall, you can see that they're actually in an arms race. Because like, what if I wanted to make sure I got 100% precision, what's something I could do with this, this square? Should I make this square smaller or bigger if I wanted precision to be 100%? So let me ask you guys this instead. If I instead drew a little guy around here, if I drew a square that was just this square, what's my precision?
100%.
100%, right? So I have one element here, right? There's only one that is correct, right? True positive, cool, right? And then I have only, hey, one element in there. Hey, 100%, awesome, amazing model. This model is the best, right? So your precision looks really high. However, what's my recall look like? My recall, if you remember, it was 12 elements in here, right? Was only 1 out of 12. Very, very poor recall, right? So you can see here is that even though precision looks really high, my recall actually dips down quite low. So going off another one, what could I do for recall that would increase recall to make sure I got all the ones that are positive, that are actually positive? How can I make sure that I capture all of these so I make recall 100%? I'll give you a hint. We made the square smaller to get higher precision. What would you think we needed to square now? Yeah, bigger, right? So I don't know. I think I've told you guys this before. My wife's seen like my recording or like me talk about this. It sounds like I'm like talking like Blue's Clues. But yeah, definitely, right? We make this thing bigger. So we basically have it so it includes everything. So everything we ever get is just positive. I don't care what feature it is, it's positive, right? Well, if you look at that, I basically have all 12 that are marked as positive and basically all of the true positives. So I get basically 12 out of 12. Sweet, right? It means my recall is 100%. Precision, as you guys probably guess, is going to be really small, right? Or at least smaller. So you can see here is that sure, I got all the positives here, but I also got a bunch of these negatives in here. So this was 12, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's that? Was 12 out of 22 then? So 12 out of 22. So like just over half, right? Like you can see I'm just barely over 50%. So you can see here precision has suffered by me trying to make recall happen. And essentially that's what it comes down to. It's like which two do you prefer over each other? And that's where this balance between precision and recall. Essentially you can make your model more like avoid, like you can make any model avoid false negatives. You can, by basically just saying everything's positive, you'll avoid false negatives. Nothing is ever labeled as negative. But of course that will affect your precision. You'll get perfect recall. Similar, if you have high precision, you can make sure that you only say if this for sure, like if you're like really, really close to being sure, like I'm pretty sure this is positive and only marking those ones. Your precision will be really high, but your recall will be low. Okay, and that's the trade-off that you go back and forth. Okay. And it depends on the situation where you might want higher recall or higher precision. So I'm just kind of reiterating this is basically all the true positives over selected positives. It's just reiterating this exact part, but just kind of talking about true positives versus all positives. Okay, so comparing these two, like I said, essentially what we can do for high recall, we can say everything is positive. No matter what, it's always positive, right? High recall. But high precision, we can say, I don't want to make a guess unless I'm not near 100% certain. Like if I'm not 100% certain, I'm not going to say it's positive, right? Which will technically get you higher precision, but your recall is going to fail in the sense that you're going to get a lot more false negatives. Okay. So last part, any questions on this kind of graph? Sound pretty good? Thumbs up, thumbs down. Okay, cool. I want to make sure you guys got that as well as they can. And I know that sometimes it can be really confusing. To be quite honest, are you going to remember this precision recall off the top of your head? Probably not. It's going to take some time until you see this over and over again before you can probably reliably have precision recall in your vocabulary where you can talk about it easily. But hopefully it kind of gives you an idea of what's going on. So our last part is another one which we typically already think about is accuracy. So you can say how many true positives, how many true negatives do we get versus all observations. So we can say essentially right here, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So what's that? 12 out of 22. So 12 out of 22 would be the accuracy. Basically, how many did we get right? How many did we correctly identify over all the possibilities? So accuracy is kind of like usually our go-to. I think most people are familiar with this. If I were to say, how well did this model do? They probably would use accuracy in some level. But precision and recall will give us a little more nuance to this part. But I want to throw an accuracy in there. Okay. So I might have enough time to finish this up. So last couple of parts, F1 score. So F1 score, basically it says, well, you might say, well, what if I want some precision and some recall? How do I know which one should I use? Well, that's where F1 score basically comes in. And basically it's a way, it's called the harmonic mean, but essentially what you could say is a balance between precision and recall. Essentially, we care about precision and recall equally. So we want to optimize both of them. We don't prefer, false negatives or prefer, false positives and false negatives are both important to us, like equally. So that's where we get this F1. Oops, I don't know what this is. Oh. Sorry, that's gonna bug me if I don't fix it. There we go. Okay, so our F1, close enough. F1 score, right? So it's equal to basically 2 times its precision times its recall plus, or divided by precision plus recall. So essentially this allows us, it will always fall between 0 and 1. So note that if precision is 0, right? Okay, that will basically give us 0. If we get 0 for recall, that will also give us 0. So we need to have something that's balanced between the two. Essentially, getting a very poor precision or getting a poor recall is not good enough. We need to have some balance in there. So that's where this top part basically is being multiplied together. Okay, so that is our F1 score. Again, if you're curious, that is called the harmonic mean. Essentially, it punishes extreme values. If you have a very, very low precision, it's going to affect even if your recall is very, very high. You can have like a near, remember recall can only be up to 1. You can have a near 1 recall, but if my precision is very, very small, then guess what? It's never going to work. What's the highest this number can be? I'm going to get. I gave you a hint. It's not 0. What's the highest precision can be? I can see someone's hand move up. It's 1. Yeah, good, Hazel. All right, so yeah, I think I've told you guys this story before. I used to have a professor who's talked about this professor who said like his professor would always ask, like, and what is this number? And there was always a guy who would either yell 0 or 1 because usually the answer is like 0 or 1. Kind of same idea here. Precision is 1, right? That's highest. Recall is 1 at its highest. So essentially what happens, we have 1 plus 1 is 2, but 2 times 1 times 1 is 2, so 2 over 2, 1, right? So that's the highest the score can be. And since we can't have negatives, we know that the highest score, the lowest score of this can be 0. So F1 score will go between 0 and 1. So again, a nice little statistical thing, right? Makes it easy for us to optimize for. Okay, so this leads us into one last part, is the F beta score. So the F beta score, that's gonna bug me. I'm gonna have to fix that later. F beta score basically allows you to adjust the F1 score and say, well, what if I care more about something like precision? So if I have an F2 score, so beta basically meaning like whatever number you want, I have an F2 score, an F3 score. Basically you're saying you care more about precision. So note that basically off the equation, 1 plus beta squared, which remember beta is just gonna be some number that you give it, times precision, times recall, and then beta squared, whatever that number is, times precision plus recall. So it basically says, what's going to be weighted more. So in this case, precision is going to be boosted by that by that beta right here. So essentially you're saying, what do you care most about? And note that the reason why it's defined this way as F beta score is because then F1 score will work here. If I put 1 in here, it'd be 1 plus 1, or 1 plus 1 squared, 2. And then 1 squared is just 1, so just precision plus recall. If you want the other direction, you can also do a 0.5 beta score or a 0.25. Basically, you can go the other direction to say, well, I want to boost the other one, either recall or precision, depending on which one you care about. And this is basically coming to the fact that sometimes you care about false positives more, sometimes you care about false negatives more. And you have to decide. And usually this ends up being more about the standard in like its field of saying, what do you care the most about? Okay. Cool. Sound good to everyone? All right. Any other questions then on F1, precision, recall, maybe accuracy? No? Sound pretty good?